All right, let's get right into it. Today, we are diving deep into the world of virtualization to settle a pretty big debate, RAW versus Qcow2. You know, if you've ever fired up a virtual machine, you've probably faced this choice. And the format you pick, it actually has a huge impact on performance, on storage, and on the features you get. So let's unpack this and see what really makes these formats tick. So you look at these two files, right? On the surface, they seem to do the exact same thing. You've got a disk.raw file and a disk.qcow2 file, and they both act like a hard drive for your VM. But what's really going on under the hood? Well, it turns out they work on completely different principles, and each one comes with its own unique set of strengths and, yeah, some trade-offs too. So here's how we're going to break it all down. First, we'll cover the absolute basics, what a disk image even is. Then we'll look at RAW and its obsession with performance, and then Qcow2 and all of its amazing features. After that, we'll put them in the ring, head-to-head, look at some real-world use cases, and then wrap it all up with a final verdict and how you can pick the right one for your project.
All right, first things first. Before we can really compare these two, we gotta be on the same page about what a disk image actually is. This is the bedrock of all virtual storage.
You know, at its heart, the idea is incredibly simple. A disk image is really just a single file that lives on your computer's physical hard drive. But to your virtual machine, that one file is everything. It looks, acts, and feels exactly like a real physical hard drive. It's this clever trick, this abstraction, that makes all of this virtual storage magic possible. Okay, let's move on to our first contender, the RAW format. And a good way to think about RAW is to picture a sprinter. It's built for one thing and one thing only: pure, unapologetic speed. And the secret to RAW's incredible speed is just how beautifully simple it is. I mean, look at this diagram. There's no extra layer, no complicated formatting. When your virtual machine writes data, it's a direct one-to-one mapping straight to the storage file on your host. This means there is practically zero performance overhead. It's about as close to bare metal speed as you can possibly get in a virtual environment. So what does this direct mapping actually mean in the real world? Well, it's a story of give and take. First, the entire disk size is pre-allocated. That means if you make a 100 gigabyte raw disk, it instantly eats up 100 gigabytes of your physical space, right from the start. Second, you get zero built-in features. No snapshots, no compression, nothing fancy. But the reward for giving all that up? You get the fastest possible input/output performance, period. And that really just boils it down to this one simple truth. With RAW, you get maximum performance, but you have to accept minimum features. It's a powerful, straightforward trade-off that is all about speed. And now for our second contender, Qcow2. If RAW is the sprinter, then Qcow2 is the versatile Swiss Army knife of virtual disks. It's just packed with tools for almost any situation you can think of. Now, let's break down that name, because it actually tells you everything you need to know. It stands for QEMU Copy on Write version 2. That copy on write part, that's the secret sauce. It's the mechanism that unlocks all of its incredible features. And because it's so flexible, it's become the go-to standard for modern virtualization and cloud platforms like KVM and OpenStack. And wow, what a feature set it is. Because Qcow2 adds that layer between the virtual disk and your physical storage, it can do some really powerful things. We're talking about taking instant snapshots to capture the state of your VM. It supports thin provisioning and compression to save a ton of disk space. You even get built-in security with AES encryption. It's basically a complete toolkit for managing your virtual storage. So the takeaway here couldn't be clearer. Qcow2 is all about flexibility and being packed with features. It's built from the ground up to prioritize flexible management over that raw, bare metal speed we saw with RAW. Okay, we've met the contenders. Now it's time for the main event. Let's put them side by side and really see how they stack up when you compare them directly. First up, storage allocation. And this visual really shows one of the biggest differences. A 100 gigabyte raw disk, boom, takes up 100 gigabytes on your host drive from the moment you create it. But a 100 gigabyte Qcow2 disk, it might start out as just a few megabytes and only grow as you actually add data. That's called thin provisioning, and it is a massive space saver. Next up, the big one, performance. Think of it like this. RAW is a direct highway. Your data flows straight to the physical disk, no stops. Qcow2, on the other hand, adds a metadata layer. It's kind of like a little toll booth. Every time you write data, it has to be checked. And that enables all those great features, but it also introduces a tiny bit of performance overhead. Now, it's important to say on modern systems with super fast storage and caching, this overhead is often so small you'd never notice it for most tasks, but it's still there.
But that little performance toll buys you something incredibly powerful. Let's talk about what is, without a doubt, QCOW2's killer feature, the one thing that often makes the decision for people: live snapshots.
So how does this magic work? Well, it all goes back to that name, copy on write. Let's walk through this diagram here. You start with your base disk image. When you take a snapshot, that base image is essentially frozen. Now, when your VM wants to change a block of data, the QCOW2 driver doesn't just overwrite the original. Instead, it copies the original data somewhere safe and then writes the new data. The file's internal map just gets updated to point to the new block. This lets you create this whole tree of changes, allowing you to instantly save the state of a VM and roll back to any snapshot whenever you want. It's brilliant. And on the other side of the ring, it's pretty simple. The RAW format has absolutely no built-in way to do this. Sure, you can use external tools, but the format itself gives you no native support for this game-changing feature. So, with all of that in our heads, how do you actually pick one? Let's move away from the technical stuff and get into some practical, real-world scenarios that should make the decision a lot clearer. You should be reaching for RAW when every single microsecond counts. We're talking production databases, high-frequency trading systems, or any super intensive I/O workload. In these scenarios, that raw performance boost is more important than any of the fancy features.
And when is QCOW2 the right call? Pretty much everywhere else. If you're doing development and testing, the ability to take a snapshot and roll back is just priceless. For cloud providers that are deploying thousands of VMs from one base image, the copy on write and thin provisioning saves an insane amount of storage and time. Basically, if you value flexibility, backups, and smart storage, QCOW2 is your answer. We're just about at the finish line, so let's wrap this up with a final verdict and a really, really useful tip. Whatever you choose, you're not stuck with it forever.
And this is maybe the most empowering part of all. You are never locked in. There's a utility called Qcow image, and with a simple one-line command, you can convert a disk from Qcow2 to RAW or from RAW back to Qcow2. This means you can get the best of both worlds. You could develop your application with all the flexibility of Qcow2, and then right before you go to production, convert it to RAW for that maximum performance. So, let's just boil this whole thing down one last time. On one side, you've got RAW. Its best feature is pure, simple speed. Its main trade-off? No features. On the other side, you've got Qcow2. Its key feature is flexibility, especially snapshots. Its main trade-off is that tiny bit of performance overhead. It's the classic showdown, pure power versus versatile functionality. And there you have it, the complete breakdown of RAW versus QCOW2. You've got the knowledge now to pick the right tool for whatever job you're doing. So the question isn't just which one you'll choose for your next project, but it makes you wonder, as our hardware gets faster and our software gets smarter, will the raw speed of RAW always be king? Or will the incredible features of formats like QCOW2 eventually just become the standard for everything?